Hello everyone, let's continue our chapter number 1, that is electric dipole. So today's topic is electric dipole. And what is an electric dipole? So electric dipole is a combination of two equal and opposite charges. When two equal and opposite charges are separated by a very small distance, they form an electric dipole. Let's say these are the two charges of equal magnitude and opposite sign. Let distance between them be 2a. So such type of an arrangement is called electric dipole. Why I am not taking distance a? On the place of a I am taking 2a just for sake of convenience. While we will be dealing with the derivation part of electric dipole related to electric field on axial point and equatorial point, there we will see why I am taking distance between them 2a, but that's for later. Let's continue basic things related to electric dipole. First thing is, when two charges of equal magnitude and opposite sign separated by a very small distance, such type of combination is called electric dipole. First related point is net charge of an electric dipole is plus q minus q, that is 0. So net charge of an electric dipole is 0. Second point, instead of having net charge 0 on an electric dipole, there will be a formation of electric field lines. As it is very obvious thing, when there is no charge, there will be no electric field line. But as there are two charges separated by certain distance, although the net charge on the electric dipole is 0, still they will form an electric dipole in its region of space. Second point. Third point would be related to direction of dipole. Direction of dipole will be taken from the negative charge to positive charge. So this will be the direction of dipole, and dipole is represented by P. So direction of P will be from negative to positive charge. This is the direction of electric dipole. So electric dipole is a combination of two equal and opposite charges separated by a very small distance. First point related to electric dipole is net charge on an electric dipole is 0, and that doesn't mean they will not form an electric field. They will form an electric field in their region of space despite of having net charge 0 on them. Third point that we discussed related to the direction of the dipole. Direction of dipole from negative to positive charge. Now let's calculate electric field formed due to electric dipole. So in our course we have two points where we will be calculating electric field. One is on the axis and another point that will be equatorial point. So there will be 2 points total on which we will be calculating the electric fields produced due to an electric dipole. Let's first discuss electric field on the axis of an electric dipole. On the axis, let me see whether it visible or not. Yes. Okay. So I want to calculate the electric field due to dipole at point P. So our target is to calculate electric field at point P. On the axis means there on the line joining the two charges. On the line joining the two charges, what will be the formula to calculate electric field? So this point P is lying on the line joining the two charges. On this point P, there will be two electric fields, one produced due to plus charge and second due to negative charge. Direction of the electric field uh, produced due to positive charge will be outward. So I am considering it as E plus, and direction of electric field due to negative charge will be inward, that is E minus. Let the distance between P and center of dipole, that I am writing O, center of dipole is R. Let the distance between point P and O is R. So if I ask what is the electric field due to positive charge, that will be K Q divided by what is the distance between the charge and point, that is obviously R minus A. This complete distance is R, and if we subtract out this A, that will be R minus A square. Similarly, electric field due to negative charge at point P will be K Q divided by distance square, so that is R plus A. So R plus A whole square. So the net electric field at point P, let me make it clear again. Electric field at point P due to plus charge will be read outward, that will be KQ divided by R minus A whole square, because the distance between the charge and point P is R minus A. So that will be the distance between P and Q. And electric field due to negative charge at point P will be E minus, that will be KQ divided by R plus A. So complete distance will be R plus A. Net electric field that I am writing as E will be sum of E plus plus E minus. Let's substitute the values of E plus and E minus. So that will be K q divided by, excuse me, let me write it e plus e minus, as they are opposite in direction, so I am writing minus. So k q divided by r minus a whole square plus, that will become minus, so minus k q divided by r plus a whole square. Let me erase. So what is common over here? That common is kq. So e is kq times 1 by r minus a square minus kq times 1 by r minus a square minus 1 by r plus a whole square. So this will become kq times if we solve this uh, 1 by r minus a whole square and this term, then we will be getting uh, 2a divided by, wait, this will be 4a r divided by r square minus a square whole square. If we consider r much greater than a, so we can neglect square of it, because a is already very small, and when we square a very small quantity, that becomes really negligible. So there I am getting e is equals k q multiplied by 4 a r divided by r square, and this term is 0, so r square whole square, that will become r power 4. So I am writing directly it as r power 4. One power of r is cancelled, so this becomes e is equals k q 4 a r divided by r, sorry, 4a divided by r cube. Further, if we solve it, we can write it as e is equals 2 times k q into 2a. I am writing the same thing in a different format, that is 2 times k q into 2a divided by r cube. So this is the value of electric field on an axial point due to a dipole. So this is the value of electric field on the axis of a dipole. Let this as equation number 1. Now let's calculate what will be the electric field on the equatorial line of an electric dipole. Electric